from today, from the morning, we've seen lots of presentations. Especially, we've been talking about digital transformations and high-end softwares where you generate fantastic shapes and generate complexities which we as structural engineers are troubled with, and give us lots of things to solve. So this is relatively a very small example. This is not something fantastic like we saw 21-meter cantilevers, etc. But this is just to, my take on what we are trying to do and whether we really require all these fancy softwares to complicate things. That is what. Now, previously we say a picture is worth 1,000 words, but nowadays it's different. A picture is worth maybe 1,000 iterations nowadays because those pictures keep changing and things like that. So looks a very simple structure. This is what we call as the proposed clubhouse at a very famous destination in Pune. This is called as the Jade Club. It is happening at a place near Pirangut, you can say. Again, some sentences which we suddenly feel that we may not agree nowadays. A complex idea is just conveyed with a single still image. As we saw a simple image, but then as we go along, we can always trust the architect to complicate things. I think architects are trained to sort of generate things which maybe even grasshopper will not be able to do. So I'm not trying to criticize, but this is just, as I said, this is a design with CCBA Designs. It was formerly called as Christopher Charles Benninge's Architects. You must have all been very familiar with them. We've been working with them for the last 10, 15 years. And we believe they are among the biggest grasshoppers I know. But this is a simple structure that we did previously. It was a sort of a workshop. But you can see, I mean, this could have been easily been a simple dome or whatever. But again, I mean, the geometry, the symmetry, and so many things. I mean, we can trust them to complicate things. Another small structure that we did, but again, I mean, no one gives you straight columns and straight trusses, things like that. It's another factory building that we did, about 30 meters with tandem cranes. Yeah, I accept it looks very good, but I mean, I could have done a simple PEB structure and finished this off, maybe design the whole 3 or 4 days. But then, I mean, look at this, look at the type of detail and what goes on. So when we got this picture, as I said, a picture is worth 1,000 words, they say. So when we see this, then okay, I think this looks good, not very complicated, not maybe, I mean, we are not going to spend too much time on this. So, but when we start looking at it, I mean, they will not give you just the architectural or the facade of it, but they also want the internal structure to look in a particular way. You can see here what they're trying to say. As we say, I have a neat row of columns and I would like my trusses to go from column to column. But no, the architect wants them to go from crisscross columns. Again, he doesn't want a pyramid to happen. It has to be sloping on 2 sides. The ridge is not again at the center. It is a little off. And that ridge is again taking care of all the projections that happen outside the club. We are trying to build it. We will nearly finish it, but there are some land issues now and the side is not complete. So it has been stalled. This is what they call as the Jade Club in Pune. This is a very prominent area near Pirangut, which is being developed. It is called Sunny's World. And it's about a 100-acre complex, and they are trying to, build a club in such a way that it becomes a premier club in Pune. Around Pune. Pune is famous for its clubs, they try to think of the British culture type of things. We have famous clubs like the POIC or the Deccan. So they are trying to model this something along that side. So it's about a 100-acre campus, and they're trying to build this club there. So they really want this thing to, stand out. when they said they want a special structure, we started experimenting. We started looking at different materials. Since the skeleton has to be seen, we were trying to find out whether we could use wood, which we thought would go very nicely. So we are looking at different shapes in wood. Then again, we are trying to model wood as like steel again. But somehow all these things, didn't go well with the architect also and the owner also. They really wanted to do something very simple. I mean, that was the brief. We are trying to build something very simple. So even this didn't go well with them. So we looked at all these types of materials, wood, bamboo, FRP. But then at the end of the day, we came and whatever they were trying to build, we decided that it's going to be steel. As you see, these pictures are okay. I mean, you start looking at them a little in a detailed way, you realize that it is not so simple as it looks. So I'll just, instead of taking through the whole thing, here you can see, maybe looking at these pictures, you'll get an idea of how things are getting complicated. And while doing this, we realized, we always, as we say, steel, we're looking at 2D, then we start thinking 3D. But many times even the 3D may not be sufficient because of, again, the positioning of the members itself. These details were what were shown to us, but then we modified them saying that this cannot happen. So this is basically a simple plan and elevation of what we are trying to build. You can see you have the column positions, and they want a cross between every alternate column. So we start from there. We are not going to put a truss from column to column, or we are not going to connect all columns. But this is essentially what they want us to see from below. Again, these are all, you can say, longitudinal sections that I'm showing. I'm showing you these sections just to understand what seemingly looks like a simple structure is going to happen. This is, say, the section at the first grid of columns. This looks very simple, looks very nice. As we go along the second grid, again, a little change there. Though we are trying to retain all the slopes, we have to because the roof has to be at a particular level. Then as we go on cutting sections, we realize that things are happening a little differently again. So you see, generally, the height of the top of the truss varies from 9 meters to 7 meters. And at every cross section, at every column, we are having a different section. We are having a different section because, as we say, if you are cutting it only from column to column, it's different. But if you cut it again at the center, again the shape or this thing is different. We have shown the dotted lines for us to realize what is just behind it and what is just in front of it. I'm sure, we took a lot of time to understand all this. I'm not going to make you all understand everything in 15 minutes, but I'm trying to just show you what we are happening to do. And again, the design challenges that all these, again, as we say, the architect would have loved to have just single span structures, but with this type of, it would not have been possible. So we had to put in some trusses there and some simple beams and some, just maybe a 3D pyramid sort of thing, and then everything interconnected. I think this was the simplest section in the overall project. We are lucky to have these sections in the project. So these are the sections that have been generated as we go along from column to column, and some of these are between the columns. So you can see at every level we change things, and then we start trying to analyze it, and then we get into a series of iterations of what we need to do, how we are going to use this. Again, these sort of sections where we have a huge sort of a cantilever coming out. This is about 9 meters. And the other side of it, the other line you see on the other side, goes and rests beyond the building onto the ground. So it is not, this so to say cantilever is not restricted only to the width of the club, but it goes beyond the club and it is grounded on the other side. Normally when you look at the picture there, we see that something is grounded, all those members going down to the ground, and we are very happy as structural designers. Yes, you have nice supports, and it will happen. Again, another part of the section where the ridge is now changing to the other side. So we had to, as we go along, we had to develop this series of, whether we want a simple plane frame there or whether we want a truss system, and whether these truss systems are going to be supported on alternate simple frame systems. I'll just quickly run through this. Again, you can see here, though the ridge is slightly off-center also, and the center keeps changing as you go along longitudinally also. This is where it goes down to the ground. This is the portion which they are trying to build now. Again, as we say, this truss comes out from the center of the building, and the other end is grounded on a little, maybe 6 meters beyond the building. So these are some, sort of trusses, the way they wanted the whole thing, not connecting the columns, but interconnecting the columns, but no symmetry, so to say, everywhere. I mean, 2 spans, they will have some interconnecting members, but the other 2 spans, they would rather have something else. So especially these cantilevers, we really had to think where we can give a simple member and where we need to cut it into and break it into sections with trusses. You can see the end span. We have made a truss because we have to support all these things which are coming out from there. This would have been the simplest bending moment diagram. I think this happens only in one location at this whole analysis. I mean, we would have been very happy if this would have been the section all through and through. But as we go along, it keeps changing. So here now the iterations come in. Now whether all the triangular trusses which we are going across, which we are going out of the building, are supposed to act like cantilevers, and my fascia beams becomes a simply supported member, or that becomes my supporting member and I can have this. So all these, keep on iterating. And then wherever it's grounded, it's that way much easier. So you can see that one particular cross-section, we get a very good, decent analysis results, but the rest we have to keep on experimenting of what would be the best. Next issue again would be the connections. So here we are trying to use connections, or we were choosing sections based again upon the forces there, but also upon the forces in the sense that we wanted to have all the forces to be contained within the section of this thing. We did not want any additional members to be put, or any additional plates for the connections, because then again that may not look so good. So again, our selection of some of the times the members was based upon the connection. So we had to determine what was the periphery and what was the type of force required to be resisted, and then we selected the sections there. Again, you can see a typical roof type of detail for them. But I mean, as I said, we can trust the architect to complicate things. You can see that the framing, whatever they have planned, is not from column to column, but also from wherever it is grounded. You can see the columns on the outside. These also are taken to be as supports, but then the truss would span from the last column to these grounded elements. So this was the basic first cutoff that we did. And we are now progressing. We are finalizing our design, but we are waiting for them to complete the adjacent portion so that we could begin. We have already begun with the fabrication, but till the side supports are ready, we cannot do all those things. Again, this was something that we had suggested that it should happen like this. I mean, a truss going from column to column, a simple bending moment diagram, and end grounding would be a simple beam. But somehow, this is what we got actually. Again, as you say, this particular shape or that shape of the truss was because they wanted it to be seen in the elevations. You can see the elevations are defining what would be the shape and the shape of the truss, so to say, and the alignment of the truss. So if you recall those sections, you will find that those sections are based depending upon these elevations. This is a typical layout where everything else is not happening. So we have 3 buildings like this. again, some lateral sections where you can see, though the ridge it looks to be in line, the internal cross sections are varying a lot. So seemingly simple, but as we say, we have to keep on thinking of different formations, different configurations, and try to fit into simple basic engineering analysis as much as possible. So we have started some construction now, but you can see the sides are still not ready. So it could take some time, and maybe hopefully it would be completed in some time now. This looks very strange because there is another member which is supposed to be grounded on the other side, which has not been constructed and not attached. So hopefully at the end of the day, we'll get what the architect wants.